In this lab, I'm going to show you how to read a MAC address table. I've got two switches. I've got a layer 2 switch and a layer 3 switch at the data center. Now the layer 2 switch, this is at remote office, for example. What I'll do is I'll select this layer 2 switch here. Type enable. The command is show MAC address table. The only thing showing in the MAC address table right now is a single entry, and that is the trunk port gig 21. That's this interface right here, gig 21. That's the uplink to R1. The hosts are not there because there's been no packets sent from the hosts. So to get the MAC address of host 1 and host 2 into the MAC address table, there has to be some traffic sent from the hosts. What will happen is if I send a ping from host 1 over to, say, this HTTP server, for example, what would happen is the layer 2 switch would read the source MAC address of this host. That's the interface of the network adapter on host 1, and it would install it into the MAC address table. And same for host 2. If I sent a ping or started a web page from host 2 over to HTTP server, for example, and it's the same thing, it would have the same effect. It would install an entry into the MAC address table for the layer 2 switch. It would also puts in the associated VLAN. There's the VLAN assigned to that switch port. Then there's the MAC address of that switch interface. And it's a dynamic, meaning it learned it dynamically. It wasn't statically configured. And the associated port. What I'll do is I'll start with host 1 here. Go to desktop. I'll go ping 172.16.2.1. So I've got some replies there. I'll just send it again. I'll get all 4 this time. Usually the first request timed out, that just refers to the fact that this is the first time the host is sending packets to that server, so it has to do an ARP request. So that looks fine. I'll do host 2 as well. This time I'll send the ping to the DNS server, 172.16.3.1. Okay, so all 4 replies. Okay, now I'll go to L2 switch, and I'll do the show MAC address table again. And now I've got them all in there. So there's the VLAN. They're all in VLAN 10. They have to be, since they're all assigned to the same default gateway. There's only a single VLAN assigned to that access switch. And there's the MAC address. So I pick out this one here, 1882. This is gig 11 is 1882. So that's host 2. So if I go to host 2 there, you can see over on the far right, there's the MAC address listed, 1882. That shows the MAC address right on the far right there. That's what's assigned to the network adapter of host 2. In host 1, that's gig 01. 6284 is the last 4 numbers. So I go here, and you notice there it is, 6284, just on the far right there. It shows the MAC address of that Gigabit Ethernet 0 interface. Gig 21 was already in there previously, since it's an active uplink to the router. Layer 3 switch here. You can verify the same thing. Here I've got 2 entries. VLAN 100, that's assigned to the HTTP server, and VLAN 200, that's assigned to the DNS server. So you can match up the ports here. Gig 102 is VLAN 100, and gig 103 is VLAN 200. There's the associated MAC addresses. When I communicated with a ping to the servers, what happened is the layer 3 switch now is communicating with this HTTP server, as well as the DNS server, since a ping was sent there. So what happens in the return path, the layer 3 switch notes the source MAC address of each server and installs that into the MAC address table, just like happened with these hosts here, host 1 and host 2. It's the same thing. So there it is there. Gig 102 is HTTP, and the other one is the DNS server. There's gig 102 and 103. So this is how the MAC address table is populated as traffic starts flowing between source and destination. And that concludes the lab.